In this video, I'm going to talk about convex lens ray diagrams and the lens equation. So here's a convex lens, and I'm going to put a focal point right here at 5 centimeters for this lens. And so approximately over here on the other side, another focal point, same thing, 5 centimeters. And recall that these distances are measured with respect to the center of the lens, so right there. I'm going to put an object here at about 2 centimeters. 2 centimeters here. And we're going to do two things. We're going to draw the lens ray diagram to locate the image, and then we're going to quantitatively calculate where the image appears. So first thing, the lens ray diagram. So for the lens ray diagram, we draw two rays. The first ray is parallel to the principal axis. This is the principal axis P here, I'll call it. So it's parallel to the principal axis. And right when we get to the center of the lens, right about here, we know that this ray is going to be refracted and goes to the focal point over here. So I'll draw that down there to the focal point. And then a second ray we're going to draw is right to the center of the lens, right on the principal axis, right through here. And as you can probably tell, these two lines are going to diverge, so they're not going to meet. So if you were standing on the side, you would see these rays, but your brain would interpret them coming from, if I trace them backwards, your brain would interpret them coming from a point over here, right there. So you would interpret that as a larger object, or basically a magnifying glass, on the left-hand side of the lens. So that's a quantitative lens ray diagram for a convex lens. Now we're going to go and calculate exactly where that is. How many centimeters is it away from the center of the lens? So for the quantitative part, the solution is three parts. We list the equations, so I'm going to say 1 over F is equal to 1 over dO plus 1 over d1 over di. So 1 there. And then we are going to list the variables. So I'm going to list the script F for the focal length, d0, and di. And the focal length is 5 centimeters, as we said. The distance of the object is 2 centimeters. And we are going to calculate where the image appears. So on the solve part, I'll do this in 5 little steps here as we did in class, so we make sure you don't miss any steps. So the first is the lens equation. 1 over F is equal to 1 over dO plus 1 over di. And we know what these numbers are. This is 1 over 5 equals 1 over 2 plus 1 over di. And these numbers here are, if you take 1 over 5, that's 0.2. 1 over 2 is a half, or 0.5, plus 1 over di. If I bring this 5 to the other side of the equation and subtract it, I get negative 0.3 is equal to 1 over di. And to solve for di, I cross multiply. So di is equal to 1 divided by negative 0.3, which is 3.33 centimeters, my units, negative. So there's my answer. So what this answer says that it is 3.3 centimeters from the lens, which looks about right, and it's negative. Negative implying a virtual image, meaning the actual light rays do not meet, but the extensions of them backwards do meet. So there's an example of a convex lens ray diagram and the use of the lens equation.